Bismillahirrahmanirrahim. In my last video, I explained about the multiplication of the matrices. In this video, I will explain multiplicative inverse of a matrix. Okay. Before multiplicative inverse of a matrix, I will explain about the determinant and the adjoint of a matrix. How we can find out the determinant? Determinant of a matrix. Suppose I will explain the determinant with the help of an example. Let's take a matrix A, B, C, and D. Okay, so its determinant will be denoted by the straight line which we are using for the absolute value also. First we will write the matrix in the straight line. These straight line are very important. They are showing that we can apply the property or rules for solving the determinant over this matrix. Now the principal diagonal, this one, this is called the principal diagonal. The product of the principal diagonal, A times D, subtract the other diagonal elements, C times P. So the answer will be a scalar number. Suppose I can say that scalar number as lambda, and it should be a real number. Okay, the determinant, if this is called the determinant of A, if the determinant of any matrix, in this case, if it is not 0, so it is non-singular. Matrix. If in any case, if the determinant of any matrix becomes 0, then it is a singular matrix. Non-singular matrix. In this case, I can suppose that this is equal to not 0. I will take another matrix B. If I will take the determinant of B, so put the determinant brackets on both sides, determinant, then we can find out the product of the principal elements 1 times 0 minus other diagonal element 0 times 2. 1 zeros are 0, 0 twos are 0. So 0 minus 0 is 0. As the determinant is equal to 0, hence B is a singular matrix. Now adjoint of matrix. I will take the same matrix A which I have taken before, A, B, C, D. When we are applying the adjoint on A, it is being applied on this matrix as the principal diagonal will exchange their position. This is the rule only for 2 by 2 matrices. 3 by 3 have a different method for finding the adjoint. So 2 by 2 is very simple. Only just exchange the element in the principal diagonal. D here and A will be here. Okay. And these elements, the other diagonal signs will be changed. Signs will be opposite. If they are negative, they will become positive. If they are positive, they will become negative. Like this. Means they will exchange the position and they will change their sign. They will exchange the position. This is called principal diagonal. Diagonal element. Principal diagonal element, they will change the positions, and other diagonal element will change their signs. If they are positive, they will become negative. If they are negative, they will become positive. So adjoint is done And in the previous page, I have solved the determinant also. Now inverse of this matrix will be equals to A inverse will be equals to adjoint of A divided by determinant of A. Adjoint of A is this one. I will write here D minus B minus C and A divided by the determinant of this one. Determinant was AD minus BC or CB, you can write anyone. Mostly I prefer write them in the alphabetical order. So BC. So this is done. Inverse is equal to adjoint of A by determinant of A. Adjoint of A is here, determinant of A is here. Because I use the small alphabets or I solve in a symbolic form, now I will give an example from the other numbers also, so you can be more clear about this topic. Let's take any number D, any matrix D, 1 by 2, 3 by 4, 1 and 2. So find D inverse. Before finding the D inverse, as you know that D inverse is equals to adjoint of A, D by determinant of D. We have to find this one. In this one, the most important thing is the determinant of this given matrix, because if the determinant is singular, so the denominator will be singular, denominator will be 0, and when the denominator is 0, so the fraction will be infinity. So in that case, the inverse is not possible for that specific matrix. So before that, every time we have to check that whether the given determinant, whether the given matrices, whether the given matrix is singular or non-singular. So find out the determinant of the given matrix first. 3 by 4, 1, 2. So this is equal to product of the diagonal 1 by 2 multiply by 2 minus the diagonal 1 multiply 3 by 4. 2 to cancel. So this is 1 minus 3 by 4, making the denominator same. 4 ones are 4 minus 3, or you can make it 1, 4 up, 4 multiplied down. Denominator is 4, numerator is 4 minus 3. So it is 1 by 4. So you have to write every time that it is not equal to 0. So hence D inverse is possible. It's okay. And now you can find out adjoint. Adjoint of D is change the position of principal diagonal, 2 here, 1 by 2 here. Change the sign of the other diagonal. This will become negative 3 by 4. This will also become negative 1. And now D inverse will be equals to, write down this, 2 minus 3 by 4 minus 1, 1 by 2. Divide by 1 by 4. It's okay. Denominator to denominator will go up here. So it is 4 times this one. I will write on the next page. D inverse will become, this 4 will multiply with the matrix 2 minus 3 by 4 minus 1 and 1 by 2. 4 is like a scalar number, so we will multiply to each entry of this matrix. 4 times 2, 4 times minus 3 by 4, 4 times minus 1, 4 times 1 by 2. 4 times 2 become 8, 4 times minus 1 minus 4, 4 4 cancel, minus 3, 2 times 4, 2 ones are 2. So this is the final answer for the D inverse. Starting from the top, I will explain again. We got a D matrix and we have to find out the D inverse. First we will find out its determinant. If after finding out the determinant, if the determinant is 0, so its inverse is not possible. But if the determinant not equal to 0, then its inverse is possible. Okay, because inverse is not possible for the singular matrices. After that, we will take the adjoint of D. In adjoint, we replace the principal diagonal and we change the sign of the other diagonal element. So we replace the principal diagonal element and we change the sign of the other element. After that, D inverse. Formula is adjoint of D by D determinant. So adjoint of D by D determinant. 1 by 4 dividing over here. So it will be in the reciprocal form here. 4 times multiply by this one, 4 times each entry will be multiplied, 4 times 2, 4 times minus 1, 4 times minus 3 by 4 and 4 times 1 by 2. 4 cancel with 4 and 2 times 4. 4 twos are 8, 4 minus 1s are minus 4, minus 3 and 2. So inverse of a complete matrix is done. Thank you so much, and in the next video I will explain more about the inverse also and solution of the simultaneous linear equation using the inverse method. Thank you so much. Please like and subscribe my video. Thank you so much. Allah Hafiz.